Welcome to Introduction to Video Security System, VSS Fundamentals, brought to you by Pelco. This course is a guide to the basics of any video security system. This section is called An Introduction to Camera Features and Lighting. Understanding how a camera produces an image and understanding lighting requirements of cameras can help the installer to overcome many problems in the field. At the end of this course, the learner will be familiar with the relationship between camera features and lighting. At the end of this section, you will be asked to complete a few assessment questions. The AGC feature is an electronic circuit that amplifies existing video to help a camera create an enhanced video signal at low light levels. This feature not only amplifies the video signal, but any noise that is associated with that signal. This amplification of noise can produce a grainy picture in low light conditions. Also, the AGC circuit is selectable and is usually shipped from the factory in the off position. Since AGC only operates when the light levels are too low for normal camera operation, it is highly recommended that the AGC setting be placed in the on position. An f-stop is a parameter used to measure the capability of a lens to collect light. The f-stop rating determines the speed of the lens. The higher the f-stop setting, the more loss of light. Each increase in the f-stop number will close the iris by 1/2, thus decreasing the amount of light reaching the camera's sensor by a factor of 50%. Minimum scene illumination indicates the minimum light required at the scene to get an acceptable video picture. Full video equals 100 IRE units. Usable, 20 to 50 IRE units, varies by manufacturer. The higher the amount of IRE units produced, the better the quality of the video image. The amount of reflected light is the actual light applied to the camera sensor to produce a video image. This factor also determines the image quality, especially during low light level applications. Since this factor varies from 5 to 95%, installers need to know the application for the camera design in order to properly set the limit stops for PTZ operation or the direction and angle for a fixed location. Backlight compensation. Adjust the picture to prevent objects from appearing extremely dark due to a strong backlight. It is a feature of the camera. A CCD, charge-coupled device, is a light-sensitive chip or image sensor that converts light into a video signal and delivers the signal to the monitor. A black and white CCD chip works well in infrared light and low light areas. An infrared filter, IR cut filter, is placed in the color CCD chip to mimic the human eye. An infrared filter is a filter used to remove visible light and only pass infrared light in different wavelengths. A CCD color camera in daylight without an IR cut filter will see a significant amount of infrared light, resulting in strange colors. The shutter speed is the speed of the rotation of the shutter inside the lens, measured in rotations per second. Fast, short shutter speeds, hundredths or thousandths of a second, prevent camera shake and can freeze motion in photos. Slow shutter speeds allow exposures in low light and can be used for special blur effects. A relatively new feature in many cameras is the electronic shutter. The electronic shutter is part of the imaging device and can perform close to the same function as an electronic iris. It controls the amount of light that the light-sensitive elements within the camera imager receives. Electronic shutters have limitations, however. They may not have as much range as auto iris lenses. This is an important consideration for exterior applications. If light control is totally dependent on a shutter, a manual iris lens is used instead of an auto iris. In an exterior application, the shutter may not be able to reduce light enough on bright sunny days, resulting in portions of the picture washing out. If the manual iris lens is partially closed to compensate for bright sunshine, Low light conditions may produce a dark, noisy picture. Many shuttered cameras intended for exterior use will also come with an auto iris lens. Usable video is the minimum video signal specified in the camera datasheet to generate an acceptable picture on the monitor. It is usually measured as a percentage of the full video. The picture quality of a camera is determined by the amount of light reaching the camera sensor, CCD. The more light reaching the sensor, the greater the output video signal will be. The value full or recommended video output signal value is 1 volt peak-to-peak video signal. This output signal is also measured as 140 IRE units. Resolution is a measurement of the camera's ability to reproduce detail. The greater the number of pixels, the finer the picture detail will be. Today's chip cameras list resolution by the number of pixels, picture elements the camera's sensor incorporates, or TVL, TV line pairs. The resolution of cameras can vary from 380 to over 600 TVL, or 5066 to 8000 pixels for black and white, and 330 and 500 for color. The main term to be aware of when comparing the resolution of one camera with another is the number of active pixels. If the camera datasheet does not list the resolution in TVL, TV line pairs, but only in pixels, a quick conversion can be obtained by multiplying the pixel count by 75%. This gives you the TVL resolution of the camera. Remember, only use the active pixel number, not the total pixel count.